everyone. Nice to be here. So, my name is Endre. I'm a software engineer in Formidable, where we either create or enhance our clients' digital experiences. And I'm going to talk about a use case that we had when building a GraphQL API. So the title is a bit clickbaity. Don't worry. It's not going to be about RESTful APIs, just like one paradigm that might be beneficial, or in some cases, I would even say mandatory, if you scale to quite a lot of users and requests. So some cliche, cringy statements why GraphQL is amazing. Some of them we can argue that's probably not even true. I mean, even the first one, we always hear or read in blog posts that underfetch, overfetch problem is solved. I would say probably it's not. We have introspection that we talked about in the previous talk. But I would argue that the strong type system and the well-defined contract between the front end, not just the code base, but even the team, is probably the biggest selling point. And I think that there is one element that I can go back to Tom's talk, is that like how you build up your state, I think. To get back to that point, I have another picture that I shamelessly had from another blog, Phil's blog, that basically says the same thing. Although it's not strictly relay, but like GraphQL agnostic, I would say. But that's the basic same thing, right? So you have your UI elements, and they can either through fragments or whatever, they can dictate the data need. And I think that is invaluable. This is such a good experience for front-end developers, definitely. It's pleasant to work with. So if we move this one step forward, I want to present one page that like how we can apply this. So if you've been working with e-commerce, this page is called PDP, a product details page. If you haven't worked in e-commerce, every time you go to Amazon, you got the same thing. So in this page, we can build up this thing that I was talking about, that a lot of components has a different data requirement. And you can see you have pictures, you have name, you have pricing, you have all the colors, sizes. Next to the CTA, you've got stock levels, you got reviews, and maybe you got some content at the very bottom. So you can see that we have a lot of data, and some way you have to stitch them together. And if we're using GraphQL, it's very tempting to come up with a query something like this, because it's very elegant. It's really enabled by GraphQL. So you can see that for this given UI, you have a lot of things on this query. And you can just write this as a front-end developer. That's very convenient to do so. And then you can request your data. So you can make your query like this. If you're using Relay, you can use fragments, and it's going to be stitched together. But I think the end result is the same. So, and on the back end, you have the ability to sub-resolve them. You can do whatever you want. So it's pretty convenient. What is the problem then? The problem starts to arise when you hit a certain scale. And you start to realize that you might hit performance issues and cost issues. So at this point, we need to do something to reduce them. Like, I can name a few things. There's definitely a performance issue on like a vertical scaling. If you just have too many sub-resolvers, you're gonna increase loading times and latency. But also at this point, caching could drive down the cost massively. And thanks to technologies like Stellate, you have the ability to cache your types and schemas in an effective way. Now, what is the problem? The problem is that if we just go back to this PDP page, we have a lot of different data. So how are you gonna cache this? But some data is cacheable very easily. Some are tricky, some are done. So if we recall, we have images. Images don't really change. You have the product name, it doesn't really change. But prices are a bit tricky. So imagine that you got to this page throughout, I don't know, some campaign, you might be eligible for, I don't know, 10% discount. So the price is not stable. You can't really cache it as easy. Or you might be a user that for some reason got a permanent discount, or you enter the promo code. So that is a tricky subject. And then the same might goes for this content. Just imagine that, again, the same thing. If you are a special user, you might be greeted with a different content at the bottom of the screen. The other thing that might be tricky is stock levels. So it's a bit hard to read, but there was a CTA like add to cart there. And we can assume that the stock levels are checked whenever you want to purchase something or you want to put something to your cart. So even if you're a small shop, your stock levels might go up and down. But if you're doing orders in a massive scale, they basically change every second. So that data cannot really be changed. So at this point, it's very hard to cache. So what we can do about that, like So another presentation of this is that we can imagine that we have two axes. One of them is how often the data changes, and one of them is whether it's user agnostic or it can be customized. And this is basically the same thing. So we are really happy with the data that user agnostic and rarely changes. They are very easy to cache. We don't really care about data that changes often. There is no point in actually caching that. And then customizable data, if we have a good hash key, we can cache it. So what is one solution to this problem is splitting up the queries. So getting back to the title of the talk is maybe not the most accurate title, but what I meant by making it a bit more RESTful is splitting up the queries. It's not going to be as descriptive, not going to be like as graph-like. We can't do as much fancy types, but this will definitely solve the problem that it spits out what's cacheable and what's not cacheable. And therefore, you can optimize for aggressive caching. So what we did here is we got rid of everything that is not cacheable. And also, instead of calling it PDP, we can call it product items. So that's a shift in the mentality that instead of making it driven by the UI, now it's, I don't want to say it as a resource because, again, you're going to call me like someone who's advocating REST, but this is more like making it a bit headless, making it a bit just like give me back the data, and I might do the notice stitching on the front end if it's performance related. And then, obviously, we got rid of the data here. We need other queries to fetch them. So again, I want to stress that it's very counterintuitive to have a price query when it's such an integral part of a product. But if you really need to cache something, if price is part of your product query, you need to manually disable caching. Like you need to opt out because otherwise it's going to interfere. And same goes for stock levels. And again, as I said, content can be cached, but obviously it's not user agnostic. So you have to be aware that somehow you need to identify how to cache this thing. And so that's it basically. So just the conclusion is caching is hard regardless of the tech choice. It's a very hard thing to do because you can either over cache or under cache. None of them is good. And I think performant optimization is never pretty. And what I mean by that is one of my colleagues said that, how was it like, make it work, make it beautiful, and make it performant sort of thing. And when you make something performant, you always have to sometimes sacrifice some beauty in the code. So it's not going to look as good. But I mean, if the alternative is higher costs, I think it's probably a good trade-off. And the other thing is analyze data before creating types and schemas. So not just what the UI needs, but maybe go beyond that. What are the entities that can be cached? Is it worth caching, and how easy to cache it? And think it was just 10 minutes. Thanks a lot. That was basically it, short and sweet.
Thank you.